Hello and welcome to the next video. Now I'm extending the previous project and I will be moving forward with an addition in this particular project. Okay. Now my end goal is to explain you the discrete phase modeling in ANSYS Fluent, but I'm just going step by step. Do not worry, have some patience. And in the initial case or in the previous project, we have seen a simple cylindrical flow with a pipe, the pipe flow, in which we were transporting the water from left to the right. All right, that was a very simple physics, and we have just simulated that using the Fluent solver. Now, what I'm doing is, apart from the regular inlet what we have created, I'm adding one more inlet over here, and I just want to visualize whether there is a possibility of simulating two inlet flow with one outlet. That is what we will be doing at first. Then we will be jumping into other aspects of Fluent, that is DPM here. And so I have utilized this Creo parametric software, and you can see in simple 2 steps I have just created the model over here. The diameter of the first circle is 100 millimeters, whereas the diameter of the second inlet or the second pipe is 40 millimeters. I'll just press OK and OK, and after that I've just added a kind of fillet over here, or a round. And after that, the next objective is to save this particular file at any specific location in step format. All right, now after saving it, we just have to go to ANSYS and import the file. All right, so I've already saved it. Let me just go to Fluent and select geometry, right click over here, import geometry, browse, and I've saved this one, and let me select that one. Clear? So the step file is being selected, the step file got imported over here, and you can see a tick mark. Now we need not go to the geometry and open and see whether it is appropriate or no. If you want, you can just do that and close the designing module, and after that you just have to go to meshing directly. So creating the geometry in any CAD software is very helpful. We need not be bothered about the geometrical details in ANSYS Fluent unless until specified or unless until required for the simulation. Clear? Now I will be directly going to the meshing module over here and waiting for the meshing module to open. Now what we will be doing is, we will be creating a simulation, or we will be creating a setup that will depict the flow of gas. All right, and we will see what kind of gas we can utilize, but before, let us just complete the meshing module. Now I'll be creating a simple unstructured mesh. So firstly I'll just generate and see what is the kind of mesh I will be getting, with respect to the statistics, that is the number of elements. So as of now I'm having 32,000 elements. I'll just reduce the size to 1e-2 and click on generate. Now wait for the meshing module to be completed. Now we have kind of a little bit denser mesh, but again it is coarse. Generally I recommend, it's not my recommendation, it is always recommended for any CFD simulation. You have to perform your simulation for 3 or 4 different mesh sizes, right? You have to refine the mesh for each simulation, and you have to analyze a flow variable, and you need to see what is the differences between each result with respect to the mesh size, and you have to prove that your grid or the grid of the domain is independent with respect to the grid refinement. And I will be just going with one mesh because we cannot waste our time for three meshes for each case. That will become totally kind of very large videos, and eventually you may lose interest in the completion of the total course as well. All right, now the meshing is completed. I'll just go to the geometry and turn off the mesh over here. The show mesh option is turned on as of now. Let me just tick it so that the mesh is turned off. Let me align it to normal. The left one will be the inlet 1. I'll select it, right click, inlet, XL, right? Because this is in X direction, and this is second inlet, which is in Y direction, and this is the outlet. All right, so we have the inlets and the outlet. Now remaining region of the domain will be selected and renamed as wall. Clear? So we have the inlet X over here, the inlet Y, the outlet, one face, the wall. Now what we can do is the complete solid geometry what we have imported, okay, we can just go to the geometry over here, and we can just click on this drop down icon, so that you'll be having the part which we have imported. Now if you are selecting this thing, the material will be there is an option called as material available over here in this details tab. You can just go to fluid/solid, and you can go to the drop down and select fluid. So this can be performed for the previous case also, which I haven't performed, but that is not a significant thing, but still recommended to select fluid because this is a fluid domain rather than a solid geometry, right? Now the next task will be to click on mesh and go to the mesh module over here, or mesh ribbon, click on update, and you can see the mesh is translated to Fluent successfully. Now the next job is pretty simple. We just have to go to the setup, which is available over here, and double click it. Now I will be catching you in the next video, and in the next video we will be performing a simulation. After that we will be analyzing the simulation, then we will be jumping into the details of discrete phase modeling. Let us move to the next video.